Hopefully at this point you're getting accustomed to this idea of dealing with algebraic expressions. So just like we've done many, many times, we're going to look at evaluating algebraic expressions, but this time we're going to look at multiplication involving decimals, okay? So example 5 says replace all variables with given values and simplify, and that is what it means to evaluate an algebraic expression, okay? So for part A, we have 4xy. We want x to be 1.25 and y to be negative 2.8. So we're going to rewrite this expression and we're going to replace x and y with their numerical values. So we get 4 times x, which is 1.25, times y, which is negative 2.8. Okay? Now, I know that I've got a negative here, so I need to just first, I'm going to simply address the signs. So I have two positives. When I multiply those, that becomes positive. But then when I multiply by the negative, that tells me my final product, no matter what, is going to be negative. Okay? Now, off to the side, what I'm going to do is I'm going to multiply 1.25 and 2.8, and then at the end of that, I'll multiply by the 4. So I'm going to multiply these two first, then I'll come back and catch the 4. Okay? So I've got 1.25 times 2.8. All right, I need to start by multiplying by the 8. So 8 times 5 is 40. I'm going to keep a 0 and carry a 4. 8 times 2 is 16, plus 4 is 20. So I keep a 0, carry a 2. And then 8 times 1 is 8, but plus 2 is 10. Okay? Now I need to multiply by the 2, which is technically in like the tens place. So I'm going to put my 0 for the 10 and then multiply everything by 2. So 2 times 5 is 10. So keep a 0, carry a 1. 2 times 2 is 4, plus 1 is 5. And then 2 times 1 is 2. I want to add my partial products. So I get 3500. Now let's address the decimal point situation. So my first factor, 1.25, has 2 decimal places. My second factor has 1 decimal place. That means my final product needs 3 decimal places. So I want to put my decimal 3 places back, but 3.500 is exactly equal to 3.5. So I'm going to be inclined to just write that as 3.5. Okay? So what we have now is negative, because we know the final product is going to be negative, but we have 4 times negative 3.5. Okay? So we'll do the 4 times 3.5 and then get our final negative product. Okay? So 3.5 times 4. Well, 4 times 5 is 20, so I want to keep a 0, carry a 2. And then 4 times 3 is 12, plus 2 is 14. And let's figure out the decimal points. So my first factor has 1 decimal place. My second factor has 0 decimal places. So that tells me my final product needs 1 decimal place. So that tells me this is really just 14 because 14, whoops, there we go. 14.0 is really just 14. So my final product is negative 14. Okay? And we can do the same thing for part B. We have just x times y, and we're told that x is negative 0.83 and y is negative 1.4. So I know when I multiply two negatives, my final answer is going to be something positive. Okay? So I've got 0.83 times 1.4. We've already dealt with the sign, so we can just use positive numbers over here for our side work. I need to start by multiplying by 4. So 4 times 3 is 12, so I keep a 2, carry a 1. 4 times 8 is 32, plus the 1 that I carry is 33, so I'm going to keep a 3, carry a 3. And then 4 times 0 is 0, plus 3 is just 3. Now I've got to put my 0 for my tens placeholder, and now I can just multiply everything by 1. So 1 times 3 is 3, and 1 times 8 is 8. I can add my partial products. So let's see, I get 2, 6, 11. And let's figure out decimal point situation for the product. So I've got 2 decimal places in my first factor. I've got 1 decimal place in my second factor. That means I need 3 decimal places for my product. So my final answer is going to be positive 1.162. And that's it. So we've done this quite a few times now between whole numbers or integers, decimals, and fractions. So evaluating algebraic expressions, just rewrite the expression, replacing the variables with the given values, and then simplify.